Hey guys, so in this video I'll talk about some web performance optimization techniques that I had applied on Hotstar's payment checkout, and the work was also published. I'll attach the link to it. So let's go through them one by one with some live code examples, okay? And you can also consider applying those maybe in your projects. So let's go through them. Let's start and go through all of the techniques that I've called out in this article, okay? So first I want to show you this payment checkout page, all right? And notice how the layout shifts is occurring over here, right? So if you really notice this footer that was rendered over here, it gets dragged down when the intermediate elements arrive. Secondly, there are more stuffs going wrong over here that we'll talk through, or you will realize when we'll go through the techniques. And it is, maybe it's not notable, but it will be very worse for the people who are on the low performance devices or who are in the slow network. And we'll simulate that, try simulating that behavior. So let's go through and understand what is CLS or what is cumulative layout shift. So as you can understand by these wordings, the cumulative layout shift actually means that there is some layout shift that is happening by some elements on the web page, okay? And it's called cumulative because there are 2-3 elements involved in making those layout shifts happening, okay? Okay, and we will sum those up. So what is the formula of it? We'll come through that, but let's sense of what it really means. So CLS, if a already painted element changes its position on the web page, okay, and thus re-triggering the browser's layout stage, causing stuttering and janks, and you'll feel it even worsely on the devices with the slow network. Your content will get dragged on horizontally or vertically. Anyhow, it really matters how the elements are rendering. But it's any stuttering or choppiness that a user can experience on the screen. And we'll see how Google ranks this page performance depending upon how much your score is. Okay, so if your score is 0, it's best. So lower the score, lesser the janks are. Okay, so a good score is any CLS score below 0.1. Poor score is greater than 0.25. Okay, and needs improvement is something between 0.1 and 0.25. So we would look always towards a lesser score or towards 0. It's better for the users. So what is the formula for it? Let's quickly check it. So if you really see, the CLS score is actually the multiplication of two things, and that is impact fraction and distance fraction. Impact fraction is the measure of how much impact that layout shift is giving to the users in terms of the screen space. So impact fraction would be calculated as how much space that, for example, that text is occupying, which gets dragged down, and how much space that image which comes up and drags down that text, right? How much space that image is taking on your screen, okay, in terms of viewport fractions. So I'll give you an example, okay, so that it's much better to understand. So if you really see this example, right, we have a text, it's initially occupying the 25% of the screen, okay. As soon as the image arrives, which is actually occupying 50% of your screen, the image, the text gets dragged down, and let's calculate the fraction for it. So the impact fraction would be, as I told, this 25% of the text and 50% of the image. So it's 0.75 impact fraction. Distance fraction is the measure of how much shift that text got. Okay, so since your image came and occupied 50% of the space, the text got shifted by 50%. So your distance fraction is 0.5. You multiply these both and you get a 0.375 CLS score. Now, this is just for a one set of elements. If your web page is having multiple layout shifts for different elements, you need to sum those up, and that would be your final CLS score. Coming back to how we can fix these cases. So one of the most common layout shifts that really happens always is this case, okay, that I already talked about. You have some header, you have a footer, and you want to show an ad in between. Okay, we call it as ad slots, right? If your browser does not know about that space that ad is going to occupy, your header and footer will just render like this, and when the ad or the image comes up, it gets dragged down. Okay, we just saw this. So what about, we can tell the browser somehow that, hey, please occupy some space on the browser for the image that is coming, okay, from the internet. So what we will do is we'll give the browser a hint of it. So let's go and check in the code. All right. So yeah. So if you see, I have a heading, I have an image tag, okay, which is kind of I'm downloading from the internet because I've given a URL. I've just assigned some styles to it. I want that image should have width of 400 pixels and a automatic height based on whatever aspect ratio it has, okay, and I have a footer. So is this really enough for browser to allocate the space much before it has downloaded the image? The answer is no, because the browser does not know what is the exact width and exact height, of that image. You have just told that, hey, I want a 400 pixel width. Fine, but what is the height, right? The browser does not know the aspect ratio of the image beforehand, all right? And we will see the result of this, how it looks like. So what I have done is I have simulated a 3G network which is slow enough so that you can visualize this layout shift. So you will see that the header renders, the footer renders, and as soon as the image comes up, it will drag down the text, and it will be even bad for the users who are on a slower network. So let's see how to fix it. So first thing, as I've talked about, is we should tell the browser that, hey, this is the aspect ratio of this image. It means this is the original width, okay, and this is the original height. I know, like, these original dimensions of this image. So I tell the browser that, hey, please check this and take a note of the aspect ratio of that image which is coming. And now I am wanting that a image should have a customized width. I assign a 400 pixels and the automatic height. Now the browser has enough information to really calculate the exact height because it has the aspect ratio and the width. So now if you will really reload this, you will see that your header and footer renders with a gap of that much dimension. It means browser has actually allocated that particular space, and as soon as the image appears, it looks smooth. So now this particular web page is not having any layout shifts. Now, okay, so now let's move to the second technique that I'm talking about, and is a very important aspect. So now if you will see, it's not only image that can appear before your footer and you can assign aspect ratios, right? It could be any DOM element, any component, right? Any view that can appear, right? So how do you really look to optimize this in terms of CLS score, right? So what we will do is we will introduce a concept of resizing observer, okay? And let's go through this code through which we will demonstrate this. So if you see, I have a UI running over here that has a header, right? And this red color intermediate element, right, that takes some time to really load and render on the page, right? So this red color UI element is maybe doing some calculations, or I'll just try to simulate some slow rendering component, right? It's not an image. So how do we really fix it? So here we will not really go for a 0 CLS score maybe, but we'll definitely try to reduce the score, and we'll see how, if we can arrive at a 0 or not. So if you really inspect it right now and try to generate a current CLS score, go to the lighthouse and analyze the page load. Okay, you'll see that your header and footer rendered closely, and when this red color component rendered after taking some time, the footer gets dragged down. So your CLS is obviously not 0, and we'll see how. So right now your CLS is coming somewhere around 0.052, right? So how to really lower it down even more, we'll see tricks for that. There are other aspects which I have not really optimized. We'll talk about that later, but let's focus on CLS score right now. So if you look at the code, I have a header over here, right? Which has a fixed height and width, which is good. But this middle element, right, this div, is doing some calculations and rendering. And how is this calculation happening? It's just a random thing, nothing to get inspired by that, but I've just run a 10,000 loop, okay, a counter. And when this counter is over, then I assign a flag that, hey, now you can show the middle element. So I render that. And this footer, there is no condition on that. That's why this footer renders earlier. Okay. So if you see, even the footer has a fixed height and width, doesn't matter. But what we will do right now is we will introduce the concept of resizing observer. Okay. It is a available API through browser through which you can really observe whether an element resizes itself. So over here, I have attached the observer over this div, the parent div, this element ref, and I'm looking if this element ref really got an increase in its height, right? So it means that the middle element really rendered now, okay, after doing some computation. And that is the moment when I realize that, okay, now I can maybe render the footer. Till then, I'll keep the footer hidden. So what I should do, I should set a variable or flag such as show footer as true only when the height of that element is greater than some value, right? So that's why I'm checking that, okay, as soon as that middle element ref height is greater than 50, I assign a true to my show footer. So what I'll do now, I'll use that show footer variable and then only I'll render this footer. I'll keep this footer hidden till then. So what this will do, this will actually not allow your div to render until this high computational component is rendered, and will thus avoid the layout shift of the footer text, because it will render much later at its correct place. So we will see, and now I'll refresh this and analyze the lighthouse score again. So let's do that. So now if you see, the header got rendered, then the red color and footer, almost they rendered together. So now let's see how much your CLS score is coming down to. So now if you see, your CLS score is 0 as expected. Now, one more thing, a good question that you can really ask is, hey, even this div was empty earlier, but suddenly an element came over here. So why is this div not getting accounted in the CLS? Because CLS should not be 0, right? But the truth is that for an empty div, right, when this was false, it was actually an empty div. It doesn't get accounted in the CLS score because browser doesn't really spend a lot of time layouting this div, you know. So this div actually renders just once, or it actually goes through its layout phase only once when this middle element renders. So now there is no layout shift happening in this web page. If we just go and check the Resize browser API to really understand how I have really attached. So we create an instance of resizing observer, and in the use effect, as soon as the component mounts, we just do it once. So you can actually create a hook for it so that you don't you can reuse this stuff with other components as well wherever you need. But yeah, this is just for learning purpose. So we have a resizing observer instance created when the component mounts, and I attach observer to this element via the ref, right? As soon as there is a change in the size of that particular div element, I do something over here. As soon as the height is greater than 50, I set the footer visibility to true, right? So this is how it is happening. And this is just a mock computational thing that I am just simulating that a component is taking a lot of time. That is this middle element, okay? So yeah. We are just focusing on the CLS score. Remember that there are other aspects of the web browser performance that you can also really fix, you know, and there are techniques for that. It's out of scope for this video. So let's go to the third way, that is animations. And believe me, this also actually contributes to a janky experience, right? For example, there's a device which is very low performant, a low end device, which probably does not support a lot of frames per second, right? And you just created an animation, okay, which is actually taking the layout stage of the browser. It means that, for example, there's a box and you are just changing the left property of the box, okay, on a very low performant device to really animate this box. Then this animation might look very janky for that particular user. And even though your CLS score does not really incorporate this in the formulas, but your lighthouse will really point you out that, hey, please fix this kind of animations which can really be janky to the users. So let's see what kind of animations could it be, right? So these are the animations which could be just like this, which is working by changing the left property of this box, right? So we are changing the left property from 0 to 500 pixels. With this, the problem is that your animation is actually triggering the relayouting of this box, and that is why it is bad. Okay, so you should actually use your GPU for any kind of animations you do. You need to be conservative about that as well, because your GPU is also your resource, and you should not just go and exploit it badly, so use it judiciously, not like you will put all the animations over your GPU if your website is a very animation heavy website, right? So be careful, but I'll show you how moving this animation to the composite layer, right? Not the layout stage, fix this, So as I am talking about, that browser goes through this 5 stages, right? So first you really get the HTML, you parse it, okay? You make a render tree out of it. Then you calculate the layout of each of those DOM elements, right? And you start rasterizing it. It means you are actually now starting to uh, assign the pixels and paint them, So this is how your entire cycle goes on, all right? And now the thing over here is that if you are really animating things and changing, for example, the left property, it will again go to the layout stage, do the relayout, do the repaint, okay, and then only it will be shown to the users, okay. So your layout, paint, and composite, these are the stages that it will again go through, all right. So what if we really avoid going very early in the browser lifecycle stage, right, or the elements lifecycle stage? So we can move these animations to the composite layer, and there are tricks to do that by using certain kind of CSS properties for animation. So if you really use this transform translate, okay, it will not re-trigger the layout phase. And again, I'm gonna give you an example. So this was the example of a bad animation, and this is the example of a good animation, because I triggered or told the browser that, hey, this left property will definitely change. So make sure whenever you animate it in the using the GPU. Always avoid non-composited animation and do it judiciously, because every element you really try to move to composited animation, what your browser will do, that it will try to optimize things and will move that element to the will promote to a new layer of GPU, okay, and it will create layers of GPU. That's why it will require its own memory and management. So remember that you have to balance things out and not really waste this kind of resources. So moving ahead to the another thing, which is not really a CLS related thing, but how this particular web page that you're seeing, the payment checkout page, was optimized, So for example, you can just use a React Lazy for loading those components which are definitely not needed, for a particular country, right? It not be true that all kind of wallets, all kind of cards are really a valid payment methods, right? So you have to really note that, and then you don't have to include that particular React component in your first load, so your JavaScript first load time also decreases, increasing your like decreasing your startup time, right? And also it browser gets to execute less JavaScript on the first time. So what I'm doing over here is, so all these payment method components, right, I'm trying to move it to a lazy component, right? These components will not, these are not static imports, right? As you see, these are dynamic imports. So it will not include in the initial bundle of the code that it is downloading, right, from the server. So As soon as I try to render based on whatever are the valid payment method names, for example, only debit cards is valid in, for example, in a XYZ country, then as soon as I render them, then a request will be made to my server asking for this particular debit card bundle, and I'll get the component and load it. So this is one example which I was talking about, where your DOM element could take some time to really load that middle element that we just talked about. And bundle splitting is the need for actually getting your users as fast as to your payment page, so that they can subscribe as fast as possible. So this is one way, which is obviously a lot talked about. So we'll go over to another one, which is again a very simple one. Um, it's just like how much you really care about your users. Do you want to show this ugly kind of slow loading images, right? If you don't want to do that, you can just replace it with a placeholder source, and as soon as the image gets loaded fully by using the onload of the image, okay, so you can see that what I am doing is, as soon as the image gets completely loaded, right, I'm calling this particular callback, right, this onload callback, in which I'm actually setting the visibility of image. Till then the image is hidden. It's a very small trick, but doesn't help much, but will just give a good experience to the users. Hey, so if you like the video and learned something from it, please like and subscribe the page and wait for some more exciting stuff.